Hey guys, welcome back to my channel, Math Sprint, and you are watching the 8th video of my calculus crash course. Today I'm going to be explaining some of the fundamental rules of integration. Now, before we begin, make sure you're familiar with at least these concepts, which will be very important if you want to understand this chapter in calculus. So first understand these concepts and then continue with this video. The topics to know are basic algebra, trigonometric identities, polynomials, set notation, basic coordinate geometry, how to plot a graph on a Cartesian plane, functions, limits, and continuity, differentiation and its fundamental rules, how to perform differential calculus on different types of functions, and the definition of an integral. If you want to understand the definition of an integral and much of the calculus concepts I mentioned here, you can check out my earlier videos in this playlist, which covers these topics. Do note for this video, I'm only working with real numbers and not imaginary numbers. All right, so let's begin. Here's some basic formulas to understand. The first thing to remember, when you are integrating a function that is multiplied to a non-zero constant k, that constant can be taken outside the integral. The second thing to remember, you can call it the sum rule if you want. When the integrand consists of a sum or difference of two functions, you can change the whole integral into the sum or difference of two separate integrals, as I've shown here. Now, here's the important thing to know in relation to antiderivatives. So you may recall in the 7th video of this calculus crash course, I explained how antidifferentiation is basically the reverse process of differentiation. Antidifferentiation is also called indefinite integration. If the integration is indefinite, it means that no specific value is produced. When you have an indefinite integral, all you get is a new function. You don't get any specific value like 4 or 7. A definite integral, on the other hand, can be evaluated and their value can be a specific number like 4 or 7. Now here's the important fact. When you have an indefinite integral, we have an integrated function. We get an integrated function. But we also have to add an arbitrary constant c at the end of the new function we obtained. C could be equal to anything. It could be 1, 2, 3, 2, 7, or even 0. Usually the context of a math problem will allow you to figure out what C is equal to specifically. The arbitrary constant C is formally known as the constant of integration. Why do we need to add this constant of integration? Because we know that when we differentiate a constant, we get 0. The derivative of 1 is 0, the derivative of 2 is 0, the derivative of 0 is 0. So when we anti-differentiate 0, we should get some constant logically. But that constant could be any number because any number can be differentiated to obtain 0. So when you integrate a function f of x, think of it like we're integrating f of x plus 0. The integral of f of x will get you that integrated function, and the integral of 0 is the arbitrary constant c. And that's basically why when we have an indefinite integral, we must always add the constant c to the end of the new function. All right, so let's move on to some more important rules. The first one can be called the power rule. When you're integrating a function consisting of the nth power of x, you get x to the power of n plus 1 divided by n plus 1 plus c. Again, remember, you have to add the constant of integration at the end always. So let's do a sample problem. You need to integrate 5x to the power of 10 plus 4x minus 1. Now, don't get intimidated by this problem. For your understanding, I will split this large polynomial into 3 subparts. First, let's integrate 5x to the power of 10. 5 is a constant. X to the power of 10 is in the form x to the power of n. So, using the formula, the integral of x to the power of 10 is 1 by 11 x to the power of 11. Then multiply by the constant 5 to get 5x to the power of 11 divided by 11. I added a p at the end to represent a constant of integration. I didn't want to use c because I didn't want to confuse you, because I used c in our final answer. Then integrate 4x. 4 is a constant. Think of x as x to the power of 1. So using the formula, we find that the integral of x to the power of 1 is x squared by 2. Multiply that by 4 and you get 2x squared. Again, here, q is a constant of integration. When you integrate -1, you get minus x. Here, r is a constant of integration. It really doesn't matter what letter you use to represent the constant of integration. It's an arbitrary constant. Even if this constant is divisible by 7 or something, I can still just represent it in general like p, q, or r. So our final answer after adding them all together is 5 by 11 x to the power of 11 plus 2x squared minus x plus c. All right, here is rule number 2. So when we integrate the reciprocal of a linear function, we get a new logarithmic function and the constant of integration. So the integral of 1 by x is ln absolute value of x plus c. When you integrate 1 by ax plus b, you get 1 by a ln absolute value of ax plus b plus c. Remember, you have to put an absolute value within the logarithmic function. Why? Because you must know already from working with logarithms that you cannot perform the log operator on a negative number or a 0. So take a look at the sample problem below. The aim is to find the integral of 1 by 5x plus 10 with respect to x. So you can just apply the formula directly. Here a is equal to 5 and b is equal to 10. So we get our answer as 1 by 5 ln, the absolute value of 5x plus 10 plus c. Now remember, ln refers to the natural logarithm. All right, the third rule. So if we are integrating a real constant a to the power of x, then we get a to the power of x divided by ln a plus c. Again, ln refers to the natural logarithm, just a reminder. In a special case where the real constant a is the natural exponent e, then integrating e to the power of x gets you e to the power of x plus c. Now check out one of the sample problems. Now the first one, before we do this problem, I want you to note that this requires knowledge of the laws of indices. So you may want to pause the video and maybe refresh those concepts before continuing. Okay, so we need to integrate 10 times 5 to the power of 3x plus 10. So how do we do this? Well, 10 is a constant, like the outermost 10 is a constant. Also, we know that 5 to the power of 3x plus 10 is basically 5 to the power of 10 multiplied by 5 to the power of 3x. So we have two constants, 10 and 5 to the power of 10. By the way, I'm not going to evaluate 5 to the power of 10 because that will make it too complicated with too many numbers. It's better to leave it in indices form because that's easier to read and comprehend. So now for the 5 to the power of 3x, well, that's just 5 to the power of 3 to the power of x. So 5 cubed is 125. So that means 5 to the power of 3x is equal to 125 to the power of x. So now we just use the formula for 125 to the power of x part and integrate it. So that gets us 2 times 5 to the power of 11 times 125 to the power of x divided by ln 125 plus c, including those other constants. So now for the second one, we have to integrate e to the power of 5x plus 10. We use the same method. We can take e to the power of 10 out because it's a constant. We can express e to the power of 5x and e to the power of 5 to the power of x. Now use the formula and we finally end up with 1 by 5 e to the power of 5x plus 10 plus c. Rule number 4. Okay, so now we're moving more into trigonometry. You might want to revise your trigonometric identities for this. So when we integrate a function of the form cos ax plus b with respect to x, where a and b are constant, we get 1 by a sine ax plus b plus c. Here's a good problem. Integrate 7 cos 5x plus 100 with respect to x. Just use the formula I showed above, and you'll get the answer as 7 by 5 sine 5x plus 100 plus c. All right, the fifth rule. So if we integrate a function of the form sine ax plus b, where a and b are constants, we obtain minus 1 by a cos ax plus b plus c. Here's a good problem. We need to integrate 5 sine 4x plus 3 with respect to x. So again, the 5 is a constant, so we can put it outside the integral. Then we integrate sine 4x plus 3 with respect to x. Now using the formula, we get minus 1 by 4 cos 4x plus 3. We multiply this by the constant 5, which we took out originally, to get a final answer of minus 5 by 4 cos 4x plus 3 plus c. All right, rule number 6. So when we integrate tan x with respect to x, we get ln the absolute value of sec x plus c, which is also equal to minus ln cos x, absolute value of cos x plus c, if you know your laws of logarithms. So let's do a sample problem. We have to integrate 4 sine x divided by 3 cos x with respect to x. You shouldn't get stumped by problems like these, and if you remember your trigonometric identities properly, you should be able to identify that sine x divided by cos x is equal to tan x. 4 by 3 is a constant. We get 4 by 3 ln absolute value of sec x plus c using the formula. Here's a general method for Here's actually a general method for integration. Try to modify the integrand, that is the function being integrated, into a more understandable form. You see, integrating sine x directly would have been a bit too complicated. So I made it easier by changing it into tan x, which I know how to integrate. So you should always think from that perspective. So let's say you need to integrate sine x times cos x with respect to x. You should realize that sine x times cos x is actually equal to half times sine 2x. Now, integrating half times sine 2x is a lot easier to integrate, isn't it? All right, rule number 7. So if we integrate cot x with respect to x, we get ln absolute value of sine x plus c, which can also be expressed as 5 ln absolute value of sine x plus c. So a sample problem, we say that we have to integrate 5 cos x divided by sine x. You should realize that cos x by sine x is cot x, or which is equal to 1 by tan x. 5 is a constant, so when we integrate, we finally obtain 5 ln absolute value of sine x plus c. Rule 8. When we integrate sec square x with respect to x, we get tan x plus c. You might have been able to figure this out already because we know that if you differentiate tan x with respect to x, you get sec square x. So anti-differentiating sec square x will get you tan x plus c. So let's do a sample problem. We need to integrate 5 plus tan square x with respect to x. So how do we do this? Now you might be tempted to split this integral into 2 integrals, integral of 5 and integral of tan square x. That's a good idea. Now, how do you integrate tan square x? First, you got to change tan square x into sec square x minus 1. You already know how to integrate sec square x already. You end up with 4x plus tan x plus c. Now, here's some general advice. Always add the c at the end of the integration when you get rid of all the integral signs within the parenthesis. That's a lot easier to work with. A second method, you split 5 into 4 plus 1. 1 plus tan square x is equal to sec square x, as you know. That's a 4. You now know how to integrate sec square x, so you end up with the same answer of 4x plus tan x plus c. Notice how for both of these methods, you need knowledge of the identity 1 plus tan square x is equal to sec square x. So you can really see a mix here between different branches of math and calculus. Now, rule 9. Integrating cosec square x with respect to x gets you minus cot x plus c. So an example solution. Now let's say we have to integrate minus 4 minus cot square x with respect to x. We express minus 4 as minus 3 minus 1. We know the identity 1 plus cot square x is equal to cosec square x. So integrating minus cosec square x with respect to x, we get cot x. So the final answer becomes minus 3x plus cot x plus c. All right, rule 10. Also, before we begin, you may want to revise your indices rules again so that you can follow this. When we integrate sec x times tan x with respect to x, we get sec x plus c. A sample problem, we need to integrate the square root of 10 tan square x plus 10 tan to the power of 4x with respect to x. First, we can take the square root of 10 outside the integral because it's a constant. Now we got the square root of tan square x plus tan to the power of 4x. We can take tan x out because tan square x plus tan to the power of 4x can be expressed as tan square x times 1 plus tan square x. We can apply the square root to tan square x to get tan x, and we can also apply the square root to 1 plus tan square x, which is equal to sec square x. So we get sec x. Now we have to integrate tan x times sec x, which gets us sec x. So we just multiply it with the constant root 10 and the constant of integration. Then we end up with the square root of sec x plus c. Okay, rule 11. When we integrate cosec x times cot x with respect to x, we get minus cosec x plus c. A sample problem, let's do. We have to integrate the square root of 4 cot square x plus 4 cot to the power of 4x with respect to x. We can take the square root of 4 outside the integral because it's a constant, and we know the square root of 4 is equal to 2. You may be able to draw some parallels between this problem and the previous problem. So we can take the cot x out. So when I say take out, I mean outside the square root, not outside the integral. Remember that cot x is not a constant because it contains the variable x. So it has to remain always inside the integral. Now, how do we simplify the square root of 1 plus cot square x? Well, we know the trigonometric identity 1 plus cot square x is equal to cosec square x. So we apply the square root to this and get cosec x. We integrate cot x into cosec x with respect to x, and we get minus cosec x. We multiply it with the constant 2, and we end up with the final answer of minus 2 cosec x plus c. Okay, here are the final 3 basic rules of integration for you. They're fairly straightforward. The integral of 1 by the square root of 1 minus x squared is arc sine x plus c. The integral of 1 by 1 plus x squared is arc tan x plus c. And the integral of 1 by x times the square root of x squared minus 1 is arc sec x plus c. Okay, so here's some review problems that pretty much sum up most of the rules I've covered in this video. If you remember and understand all the rules, then this shouldn't be a problem for you. I recommend that you take about 3 minutes since you're new to integration. Pause the video for now. Okay, so here are the answers for all of them. If you didn't get any of them, you might want to go through the rules again to clarify your concepts. Also, for question C, if you don't understand how to do this question, you may want to revise your trigonometric identities, because then you would know that sine 2x is equal to 2 sine x times cos x. Thank you guys, that'll be the end of this video. Make sure you hit the like and subscribe buttons to see my future videos on mathematics. Until then, stay tuned.